Have you ever gone to a concert where the music was really loud and everyone around you was screaming and yelling, and even though you might have had a great time, when you woke up the next day, you noticed that your hearing seemed a little dull? Everything seems a bit muffled. If this has happened to you, then you know that after some period of time, usually just within the day or so, your hearing will come back to normal. So this is a temporary effect, but it's still noticeable. A new study, published in the Proceedings of the National Academy of Sciences, has figured out why this happens, at a biochemical level. Alright, so first, a little bit of background information. Inside of our ears, we have cells that are equipped with stereocilia, which are like tall columns that extend off the top of the cell. They reach up like stiff hair, almost. When these stereocilia are exposed to certain sound frequencies, this cluster of stereocilia columns will be moved by the vibrations. This mechanical interference that pushes around the stereocilia will also open mechanically gated ion channels that exist in the cell's membrane. The stereocilia are grounded in a tissue called the tectorial membrane, and the tectorial membrane holds a lot of calcium ions. And when sound hits the ear and there's this vibration from the sound, and it causes this mechanical interference on the cells and the stereocilia, it causes the tectonic membrane to release calcium ions. These calcium ions will flow through the mechanically gated ion channels to move into the body of the sensory cells, and here they'll stimulate the sensory cells to send a signal to the brain that we perceive as sound. We can hear different pitches of sound because we have different types of sensory cells in our ears, with stereocilia that are moved by different frequencies of sound. These sensory cells that detect sound exist in the cochlea, which is a spiral-shaped structure in the inner ear. The tectorial membrane is kind of like the skin of a drum, which is mounted on the external-facing part of the cochlea. When the tectorial membrane is exposed to sound, it vibrates and releases its calcium ions, and these go on to activate the sensory cells. And so one of the first things that the researchers discovered was that the tectorial membrane acts like a storage vessel for the calcium ions, which releases calcium in controlled quantities to preserve the functionality of the sensory cells. If the sensory cells were exposed to too much calcium ion, it would give you the auditory feedback of an extremely loud, weird noise, and that can damage the cells. So by having the tectorial membrane act as a storage depot, it helps to protect the sensory cells, and it allows for the regulated release of calcium ions, so there's a controlled, regulated consistency to the sounds that we hear. This is actually one of the bigger discoveries of their paper, because scientists had, for a long time, thought that the tectorial membrane's vibrations had some kind of critical mechanical influence on hearing, but this new research would suggest that its role might be less mechanical in nature and more biochemical, as it has this controlled release of the calcium ions. One of the authors of the paper was Anders Fridberger, and he said, quote, "When we expose isolated inner ear cells to loud noise in the lab, the level of calcium in the tectorial membrane falls, and the sensory cells cease to function. After a while, however, the calcium ion concentration returns to its previous level, and the sensory cells start to function again." Unquote. In their paper, they explain their findings in greater detail, saying, quote, "Following these relatively mild sound exposures, similar to that experienced by many people at rock concerts, there was a significant decrease in the calcium ion concentration of the tectorial membrane. These calcium changes correlated with the amplitude changes in the cochlear microphonic potential, but not with any other physiological parameter, suggesting that such calcium changes influenced hearing sensitivity." Unquote. In much less technical terms, what this means is that your tectonic membrane stores calcium ions and releases them to stimulate your hearing cells so that you can hear. But when you hear loud sounds for a prolonged period of time, the calcium stores are depleted, and your ability to hear is thus degraded, because there's no more calcium for your tectonic membrane to release to your sensory cells. This is why you wake up the next day with some degree of hearing loss. But as the calcium stores are slowly renewed as your body metabolizes nutrients, your hearing will come back. If you listen to loud noises like this infrequently, and the sound itself isn't super loud, this long-term damage to your ears really isn't that bad. But if you listen to really loud noises, or if you listen to loud noises a lot, then your hearing can degrade permanently, as the damage extends beyond calcium ion depletion to actual morphological disturbance of the structures and the cellular organization of the inner ear. So, as with all things, moderation is critical, even when it comes to kick-ass rock concerts.